Welcome viewers. In this video we'll see the solved problem for nodal analysis by equation method. The explanation for nodal analysis available in the previous video. The link is available in the description box. The viewers can see what is meant by nodal analysis and what is meant by equation method. The explanation is available. In this video we'll see the solved problem. So the question is, find the node voltage and current through the various resistor for the circuit shown below. So this is the circuit available. We need to find the node voltage, these two node voltage, and current flowing through all resistor. Current flowing through 5 ohm, 4 ohm, all the resistor we need to find. That is the two questions. So now consider this diagram. So the two voltage sources available, 25 volt, 100 volt. We'll take this is VA and this is VB. Then various resistors are available. What is node? Node is nothing but a junction point. All the elements are connected together. So we need to assign the node as well as reference node. Reference node is nothing but common point. Normally this common point is taken as reference node. Here the potential is 0, return path. Other than that, we need to find the principal node. So we can take this is one node. How we can assign this is node? At this point, these three resistors are connected together. We can assign this is the second node. Here, these three resistors are connected together. So this is not a node. This is a normal point. So supply voltage is given here. So this is the node. At this, three elements are connected together. So we assign two nodes. The problem, the node is not given. We need to assign the node. So this point is assigned as node 1. At node 1 the voltage is V1. This point is assigned as node 2. The voltage at node 2 is V2. This is the reference node. So the question is, we need to find the value of V1 and V2. What is the value of V1 and V2? So our aim is to find V1 and V2. We can apply the Kirchhoff's current law to find this V1 and V2. We can frame the two equations. By solving the two equations, we can able to find V1 and V2. First we'll consider the node 1. We'll consider node 1. Apply Kirchhoff's current law to the node 1. What is Kirchhoff's current law? The incoming current is equal to outgoing current at a node. Otherwise, the total current in the node is 0. That is the total current in the node. What is the total current? Current flowing through 5 ohm, current flowing through 4 ohm, current flowing through 10 ohm. By adding these three is equal to 0. That is the statement given by Kirchhoff's current law. The total current in a node, in a junction point is 0. What is the current flowing through this 5 ohm resistor? The formula current is nothing but I equal to V by R. The current I equal to V by R. What is the V? What is the voltage across this 5 ohm resistor? So it is connected between node 1 and supply voltage. So the node 1 voltage is V1, supply voltage is 25 VA. So V1 minus VA, that is the voltage across 5 ohm, divided by R. R is nothing but 5. Right? So V1 minus VA divided by 5. This is the current flowing through the resistor 5 ohm. This 5 ohm connected between V1 and VA. So that it is V1 minus VA. What is the current flowing through this 10 ohm? This 10 ohm is connected between node 1 and node 2. So V1 minus V2 divided by 10 is the current. V1 minus V2, because 10 is connected between V1 and V2. So while referring the node 1, we always refer V1, V1 minus VA, V1 minus V2, like that. Then what is the current flowing this 4 ohm? That's connected. This 4 ohm is connected V1. So V1 by 4. Another end is the reference. This reference node means the voltage is 0. So for 4 ohm, it is connected between node 1 reference node, so that V1 by 4. So this is nothing but current in a junction is 0. Current in the junction is nothing but current flowing through 5 ohm, 4 ohm and 10 ohm. That is calculated. The current I equal to V by R. So all are added together. So V1 by V1 minus VA is nothing but 25 divided by 5. V1 minus V2 divided by 10. V1 by 4 that is equal to 0. We'll take this is equation number 1. We can go for further simplification in the equation. Now we'll apply the Kirchhoff's current law to the second node, node 2, this node, second node. At second node, what are the resistors available? This 10 ohm is connected, this 2 ohm is connected and 8 ohm is connected. 3 resistors are connected at node 1. First consider this 10 ohm. What is the voltage across 10 ohm? V2 and V1. It is connected between node 1 and node 2. While referring node 2, we need to take V2 minus V1. If you refer node 1 means V1 minus V2. While referring node 2, V2 minus V1 divided by 10. Then what is the current through this 8 ohm resistor? This 8 ohm is connected between node 2 and supply voltage VB. It is connected between V2 and VB. So V2 minus VB by 8. What is the current flowing through this 2 ohm resistor? It is connected between second node V2 and reference node. So that V2 divided by 2 that is equal to 0. Now we calculated current flowing through 10 ohm, 8 ohm and 2 ohm that is equal to 0. This V2 minus V1 by 10, V2 minus VB, VB is nothing but 100 voltage. So V2 minus 100 by 8 plus V2 by 2 equal to 0. Now frame the second equation also. Now we'll simplify this equation 1 and 2, then we can go for the solving the equation. Before solving this equation 1 and 2, we will simplify this. Now consider the equation 1. Consider the first equation. So this first equation is considered V1 minus 25 by 5, V1 minus V2 by 10, V1 by 4 equal to 0. Now we'll split this V1 by 5, 25 by 5, splitted. The denominator is splitted here. Similarly, V1 by 10 minus V2 by 10 plus V1 by 4. Now it is splitted, all are splitted. Now write all the V1 terms, V1 by 5, here V1 by 10, V1 by 4. Only one V2 term is available, minus V2 by 10. The numerical is 25 by 5 is 5. Right? So in this, all V1 terms are written first, then V2 term, then the constant. Now we'll take the LCM for this, 5, 10 and 4. The LCM is 20. For these three numbers, 5, 10, 4, the LCM is 20. So in the 20, 5 is going 4 times, so 4V1. In 20, 10 is going 2 times, so 2V1. In 4, 20 goes 5 times, so 5V1. Right? So this is normal simplification by LCM. Minus V2 by 10 minus 5 equal to 0. Right? So this 4 plus 2, 6, 6 plus 5, 11. 11 V1 by 20. V2 by 10 can be written as 0.1. 1 by 10 is 0.1. Minus 5 equal to 0. So the 11 by 20 is 0.55. By simplifying this 11 by 20, 0.55 V1 minus 0.0 V2. Bring this minus 5 in the right hand side. So it becomes plus 5. So we'll take this is equation number 3. 0.55 V1 minus 0.1 V2 equal to 5. So now framed the equation 1, equation 3. Now we'll go to the equation 2, then we'll go for simplification. Now let's take this equation 2. V2 minus V1 by 10, V2 minus 100 by 8 plus V2 by 2 equal to 0. Now split the denominators, V2 by 10 minus V1 by 10, V2 by 8 minus 100 by 8 plus V2 by 2 equal to 0. Now it is splitted, numerator is splitted. Now we'll write the V2 terms. What are the V2 terms available? V2 divided by 10. Here one V2 divided by 8. Here V2 divided by 2. 3 V2 terms are available. One V1 is available, minus V1 by 10. And numerical is 100 by 8, minus 100 by 8. Now we can take the LCM for these three numbers, 10, 8 and 2. The LCM is 40. 40, this 10 is going 4 times, so 4V2. In 8, the 40 in 8 it goes 5 times, so 5 V2. So the 2 in 40 it goes 20 times, so 20 V2. So this is a normal LCM. Then V2 by 10 can be written as 0.1 V1. 100 by 8 can be written as 12.5. Right? Now we can go for the further simplification. So 4 plus 5, 9. 9 plus 20, 29 by 40 V2 minus 0.1 V1 minus 12.5 equal to 0. Then we'll go for the further simplification. This 29 by 40 is 0.725 V2 minus 0.1 V1 minus 12.5 equal to 0. Now we'll write in order V1. First we'll write V1 minus 0.1 V1 plus this V2 0.725 V2 equal to 12.5. This minus 12.5 is brought to right hand side. So it becomes plus 12.5. You take this equation number 4, fourth equation. Now we have equation 3 and equation 4. Equation 1 and 2 is framed from the network using Kirchhoff's current law. That equation 1 and 2 is simplified, then we framed equation 3 and 4. By solving this equation 3 and 4, we can go for the find the V1 and V2. So this is equation 3. This is equation 4. We need to solve these two equations so that we can able to find V1 and V2. See this, in order to cancel V1, here 0.55 is available, here 0.1 is available. So multiplying equation 1 with 0.1 and equation 2 with 0.55, so that these two terms become equal, we can easily cancel. That is, equation 3 is multiplied by 0.1. Equation 4 is multiplied by 0.55. Opposite. This oppositely we multiply, so that these two terms become equal. Right? So equation 3 multiplied by 0.1 will get this. Equation 4 multiplied by 0.5 we will get this. So what is the advantage here? Both are become equal. One is plus and one is minus. So simply we can cancel. We can add this negative. So that by simply adding it will be cancelled. So by adding these two, 0.38875 V2. By adding these two, 7.375. Due to negative we are adding simply. So 0.38875 V2 equal to 7.375. Now we'll go for the further simplification. So it can be written as 0.38875 V2 equal to 7.375 can be written as V2 equal to 7.375 divided by this term. This term is brought in the denominator. So by simplifying this, what we got? 18.97 voltage. The V2, the node voltage at the second node VT is 18.97 voltage. Now we'll consider this third equation. In this, if we substitute V2, we can easily find V1. Right? So V2 is calculated. Now consider the third equation. In that, we are substituting V2 equal to 18.97 V2. So 0.55 V1 minus 0.1 into 18.97 equal to 5. Now we can multiply these two. These two are multiplied. So it is 1.897. Now bring this term in the right hand side. So it becomes plus 5 plus 1.897. So by adding these two, 6.897. So that V1 equal to 6.897 divided by 0.5. This term is brought in the denominator. So the simplifying this value, what we got? 12.54 voltage. The voltage at the node 1 is 12.54. So the first question we calculated. Node voltage V1 and V2 is calculated. Second, we need to find what is the current flowing through each and every resistor. Now we'll find the current flowing through. There are 5 resistors available. So the current flowing through the 5 ohm resistor is nothing but VA minus V1 by 5. This already we discussed while framing the equation. So VA is 25 minus V1. V1 we calculated 12.54 divided by 5. It is 2.492 amperes. Then current flowing through the 4 ohm resistor is V1 by 4. So this thing already available in the diagram that already we discussed. From that you can easily understand. So V1 by 4, 12.5554 by divided by 4, it is 3.135 ampere. Current flowing through the 4 ohm resistor. Current flowing through the 10 ohm resistor is V1 minus V2 divided by 10. So 12.54 minus 18.97 divided by 10, that is nothing but minus 0.643 ampere. This is negative. We got the negative value. Then current flowing another 2 resistors available. Current flowing through 8 ohm resistor is VB minus V2 divided by 8. VB is 100, supply voltage, second supply voltage 100, minus 18.97 by 8 is 10.12 amperes, positive only. Then current flowing through the 2 ohm resistor, V2 by 2 equal to 18.97 by 2, that is 9.485 amperes. Now we calculated the current flowing through all 5 resistors. So in this problem, we calculated the node voltage V1 and V2 by using the equation method, and current flowing through all resistors. The explanation of node voltage, that is available in another video, and matrix method also available in separate video. The link is available in the description box. The viewers can see the link and you can see the nodal analysis explanation. Thank you.